Hello and welcome back. In this part 15 we are going to add the bottom vertical stiffness, and then we are going to use the mirror tool to mirror these two across the ZX plane. To add the bottom stiffness we are going to reuse this one. Okay, so as we did plenty of time before, we select it, and with the copy option active we'll move it, let's say 200 millimeters. Now we have a new copy. Then we will move it back to the original position, 200 millimeters. And now the two stiffness are setting one on top of the others. Okay, so right click again and replace part with copy. Then you rename it S8. Then save. And now we can go ahead, edit in place. Now we will show the assembly geometry and all this reference geometry inside the stiffness. Okay, surely we don't need this first interpart copy, so we'll just delete it. Now we go ahead and edit the profile of the protrusion. So edit profile, normal 2, and we will remove the constraint we added between this endpoint and the endpoint of this line. So we will use the quick pick for that. So we move close to the endpoint, then using the quick pick we make sure we select the constraint we want to delete, so this one, and we'll do the same at this endpoint. So we will remove this one, so select it and then hit delete on the keyboard. And for the bottom stiffener we will align this edge to the edge of the cutout on this mounting plate, and we will have a 45-degree angle and this 55 millimeters dimension. Okay, so we have to make this dimension driven, so we can select this endpoint and move it underneath like this, and we do the same for this one. Okay, now we can move it, and now we will constrain this endpoint to this one, and we will make this line collinear to this edge. And now all we have to do is to change this dimension to 55 to 75 millimeters, and that's it. This dimension is not useful, so we will delete it, then close sketch and finish. Okay, now the extend and the stitch are not really useful. All we need is the subtract, so you just select the two features and hit delete, and as you can see the subtract is properly computed. Okay, now we will close and return, and we will create the mirror copy of these two stiffeners. Okay, so to create the mirror we use this mirror components tool, and the first step is to select the component to be mirrored. So this one first and the second one, then right click to accept, and now we have to select the reference plane, so it will be this ZX plane, and we have this dialog box from which we can define how we want the mirror to be performed. Okay, so we have these action columns which will define how the mirror copy will be created. So you have the rotate option, and you can see you can rotate about the XY plane or any other plane you want, or you can use the mirror copy, which create a copy of the component you are about to mirror, and this copy will have a different name because in this case the two sides are not exactly symmetric or identical. That's why we'll have a different instance. And a third option is to the exclude, and this component will not be mirrored, so we'll use the mirror option, and we will leave the names underscore mir. Okay, and I will make sure that I also select this component. Okay, and the copy is created. Okay, now I can just hit finish, and components to be mirror cannot be created. This file permission. Okay, I don't know what is happening. Okay, so the mirror copied created only this one. Okay, we'll try again. So you select this component, this plane, then okay, and finish. Okay, and that's it. Okay, now that this side is finished, we are going to go ahead and create the mounting plates and stiffeners on this side. Okay, we want to first show the reference component, and it will basically be this 7/8 sheet metal component. So we are going to look for 7/8, and maybe we should make sure that we have the stiffness configuration active first. So 7/8, and we can also show the mirror copy, then this one, and save the configuration. We are going to copy this part, this one and this one, and we are going to reuse them to create the other side. Okay, so we will move this time the steering wheel to the origin of our base coordinate system, and as you can see, the steering wheel is not oriented as we want it. So to properly orient the steering wheel, press the shift key and click on the steering wheel plane, so this area in the center, and as you can see, the steering wheel change the orientation as we are selecting the plane. Okay, now we make sure that we have the copy option, so move copy, we will rotate 180 degrees. Now we will select the component, then right click more, replace part with copy, and we'll rename mounting plate 2, save. We'll do the same for this one, so right click more, replace part with copy, and this one will be stiffener 9, then save. And for this one, replace part more, replace part with copy, right click, and stiffener 10. Save. Okay, the last step is to make this component grounded, so we have this one, then this one, this one, and this one, then escape, so that we leave the ground command. Okay, now we'll start with escape. Now we'll start with this one, so edit in place, Ctrl Q, and the first thing to do is to make sure we use the right reference geometry. So we'll select this component and this face, and we'll dive inside the protrusion, then normal 2, and what we want to change is this dimension, and the value should be this one, 1000. So 1000. Then we will leave this to 450 and this to 400. Now you can close the sketch, right click to finish. Now you can see the subtract fence, and the reason is this surface is not crossing entirely the protrusion. To fix that, we are going again to extend this face. So extend, select this edge and we push it a little bit upwards like that, then right click to finish. And this extend should be before the subtract, so we have to reorder the features, and to do that we just select the extend and move it up to the protrusion and then drop it. The features are reordered and the extend is now before the subtract, and as you can see the cutout is now properly computed. Okay, so now we will edit the cutout to remove this profile. We do not need that anymore, and now we will close the sketch and we will be done for this mounting plate. Okay, close and return to the assembly. Now time to edit this mounting plate. Edit, Ctrl Q, and maybe before we get to that we need to show this component. So I think it is 6.7. Okay, and now we will edit the reference geometry. So this interpart copy should be this face of this component, then finish, and this one should be this component and this face. Now we reposition the protrusion, so normal 2, and as we did before we are going to remove the point on constraint and on this endpoint 2, and we are going to reapply them, this point to this edge and this point to this endpoint, and it doesn't work like expected, so we will undo and maybe first move this like that, so to 540, and now we will connect this endpoint to this one. Okay, now we will apply the proper value for this dimension. It should be 90 and this angle 40 degrees. So 40 and this 90. Okay, now we can close the sketch. We do not need this second interpart copy, so we just delete it. And now we have the extend, we do not need that. The stitch also, and the subtract is automatically properly computed using this interpart copy surface. And that's it for this stiffener. Close and return. Now this one. First thing, we update this geometry. So we'll use this one, this face, and then the profile. So first we make sure that we decrease this to 540. Okay, see, the value is inputted but the dimension is not updated, and this is because we have some failed constraints here. Okay, I will go first normal 2, and we will remove this constraint and the connect constraint we have at the endpoint. Okay, this one. Now you can see the value is correctly computed now. Okay, so we just have to move this like this, and then we will make the line and the edge collinear, and connect constraint the endpoint of this line with the endpoint of this edge. I can't say if it is really necessary, but maybe I should undo the collinear first, then I will constrain this endpoint to this endpoint, and then I will make the line collinear with the edge. Okay, better like that. Now this distance is 40, and maybe I should increase, or not a big deal. Now we will close the sketch and finish, and there it is. Now we close and return to the assembly, and again we will use the mirror tool to mirror these two stiffness. Okay, so mirror components, this one and this one, right click, and we select this plane, we keep the mirror option, and OK, and finish. Et voilà. So far so good. Now we will make the added components visible in the stiffness configuration. So these two mirror visible, and maybe this component also. Then save. Take a look on the default configuration, and I don't know why this is keep happening. So you select all the components, make them visible, these also, and then save. Okay, we are pretty much done for this tutorial. Almost all the parts are in place except the two buses, which are basically ports for measuring equipment like nanometers and stuff like that. Okay, so we have to do these two to conclude this tutorial. Okay, so we'll start with this one. We'll add a new component, right click, and we will name it B1 as boss 1. Then we will use this component as reference geometry, so the component is 3, 4. basically this one. So home, interpart copy, this one, this face. Now we can Control Q and we'll create a protrusion from a parallel plane. So it'll be this plane, and now the distance is not given on the print, as well as the diameter of the boss. But for the diameter, we can guess that it will be the same one as this one, so 60 millimeters. And for this offset, we are going to guess it is somewhere around 650.5 millimeters, and we are going to go ahead with this value 650.5 and click to position the plane. Now normal 2, you will use the cycle by center point tool. Make sure it is aligned horizontally with the x-axis. Now the diameter dimension should be 60, and the distance from the y-axis to the center point should be 105. Okay, now we can close the sketch, and for the extent of the protrusion, we are going to use this option from to extend. Okay, so now the first step is to define the from surface, so this step, and we have the option to right click to accept the profile plane as the front surface. Okay, so we will just right click, and you can see we have moved to the to surface. So the to surface will be this face. You can see as I pre-select this surface how the extrusion is created, and you can add an offset if you want, but for this case we'll just select the face and that's it. Finish and cancel. Now we have to create this threaded hole. It is a straight pipe thread hole 1/2, and because it is crossing through two parts, we cannot directly create it inside this part. We are going to create it at the assembly level. Okay, so we are going to close and return. Then on the features tab in the assembly, you will select the all features. We are going to make sure that we will create assembly driven part features. Then okay, we select this face as the coincident plane. Then we will change the all parameters, so we create what we want. So we want straight pipe thread, and we want the type to be G1/2, so this one. Okay, the extent will be something close to, let's say, 20 millimeters, and from the all extend we will select this option again from to extend, and okay. And now we have to position the hole, so we make sure that we have this peer edge locate active, so that we can reference this edge and snap the hole to the center point of the circular edge. Now we can close and exit the sketch, then diametric view. Okay, as you can see, we are now on the to surface step. We skip the from surface because it is the all command. The all command automatically knows that the surface you pick as the coincident plane is the from surface. So now you just have to define the to surface. Okay, we are going to select the x y plane to define the to surface, so select it, and now you can see we have these two components pre-selected. So we just accept the pre-selection and hit finish. Now you can see the hole is created. If we take a look on this component, we'll hide this. You can see how the hole is created in the part and a hole feature is added, and the same applies. Let me zoom fit. The same apply for this component also. You can see we have a hole on the component. Okay, now we can close and return, and we'll stop here. In the next part, we will create the boss on the mounting boss on this side, and we will add the last stiffeners, and we will also take some time to add some finishing details, and we will then conclude the tutorial. Okay, hope to see you then, and thanks for watching.